So we know that the logarithmic function with the base of a is the inverse of the exponential function with that same base of a. I forgot to write the word inverse. So let me write that down a second. So that therefore probably should have some pretty similar properties. So we talked about the product property, the quotient property, and the power property for exponents. We have similar properties for logarithms as well. So for example, log base a of u times v is the same as log base a of u plus log base a of v. Let me give you an example of that. So if we have log base 3 of 27. Well, that one we can kind of do in our heads. That one's just 3. But let's break it up a little bit. We could actually break that up into log base 3 of, I'm going to write 27 as 9 times 3. So if we split that up, it'd be log base 3 of 9 plus log base 3 of 3. Log base 3 of 9 is 2. Log base 3 of 3 is 1. So it ends up being 2 plus 1, which is 3. Now again, we could have figured that out because 3 to what power is 27? Well, that's 3. But I just wanted to show you why that property works. The quotient property is pretty similar. Log base a of u divided by v is the same as log base a of u divided by log base a of, minus log base a of v. So if we do, say, log base, let's do 4 of 64 over 16. Now 64 divided by 16 is 4. We could do that and we'd end up log base 4 of 4, which is just 1. But if we split this up into log base 4 of 64 minus log base 4 of 16, well, log base 4 of 64 is 3 because 4 to the third equals 64. And then log base 4 of 16 is 2, so minus 2. We end up with just 1. And again, as I said earlier, this one we could have just said, well, it's the same as log base 4 of 4, which is 1. Now the last one, the power property, really is derived from the product property. So log base a of u to the n is the same as n times log base a of u. Let me demonstrate how that's the case. So I'm going to choose two random numbers. Log base 7 of 4 to the 5th. And I'm going to write it, do a little smaller exponent, so I don't have to write quite as much. Now, 4 to the third is the new one that I'm choosing. 4 to the third really means 4 times 4 times 4. Now, using that product property, so this is now a product of 3 4s, we can make it into log base 7 of 4 plus log base 7 of 4 plus log base 7 of 4. I feel like I said the same thing 3 times because I did. So log base 7 of 4 plus log base 7 of 4 plus log base 7 of 4, we can make it into 3 times log base 7 of 4. For the product property in general, my suggestion is take the exponent, move it out front. Now, all three of those properties also apply if using the natural log. So the natural log of u times v is the same as natural log of u plus the natural log of v. Natural log of u divided by v is the natural log of u minus the natural log of v. And then natural log of u to the n is the same as n times the natural log of u. So all those properties hold true whether you're regardless of what base you're dealing with. So log base a, log base 10, log base e, aka the natural log, all those properties hold true. On the next page, we're going to try to apply those properties. So I forgot to erase that page since I last did it. The first part, it says, write each logarithm in terms of ln of 2 and ln of 3, the natural log of 2 and the natural log of 3. So looking at this first one, natural log of 6, well, 6 is the same as 2 times 3. So let's start with that. So I'm going to do, natural log of 2 times 3. So it's a product there. So since it's a product, we can use the product property and we get natural log of 2 plus the natural log of 3. So just writing it in terms of natural log of 2 and natural log of 3. Now natural log of 2 over 27, if we use the quotient rule because we have a fraction there, we got the natural log of 2 minus the natural log of 27. Okay, so great, we got that natural log of 2, we were hoping to get that. But now that natural log of 27, we want to have that in terms of the natural log of 3. Well, 27, I'm just going to rewrite the natural log of 2 a second. 27, we could write it as natural log of 3 to the third. 27 is 3 to the third. So we've used the quotient property to separate them out. Now we're going to use the power property and move that out front. So we end up with the natural log of 2 minus 3 times the natural log of 3. So we can get those in terms of natural log of 2 and natural log of 3. Now down below, it says expand each logarithmic expression. That means break it up as much as you can. Now it's actually, I probably could go a little further on a couple of these, but we're going to break it up. So this first one, log base 4 of 5x to the third y. That's 5 times x to the third times y. So we're going to use those properties from the previous page and break this up. So this is 5 times x to the third times y. It's a product. So we're going to break it up to log base 4 of 5. Using the product property, we're going to add log base 4 of x to the third plus log base 4 of y. So using our properties that we have so far, we use the product property and break it up. Now, one other thing we could do is we can take this 3 and move it out front. So we can make it log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. Technically, we can go a little bit further if you want, but honestly, this is probably where I'd stop if I were you. A little bit further, we could actually break that 3 log base 4 of x up into, and this is going to be overkill, log base 4 of 5 plus log base 4 of x plus another log base 4 of x plus another log base 4 of x. It's kind of like just breaking 3 times something into 3 separate. So if you want to get excessive with it, you absolutely can. You do not have to, but we could. That's the longer way. In general, the one that I have in the box is probably the preferred way. We use the product property and we use the power property. Now letter B here, natural log of a fraction. So we've got a fraction here, aka quotient. So let's break it up into the natural log of the numerator, so the square root of 3x minus 5, minus the natural log of the denominator, so using that quotient property. Now, the square root, none of the properties in the previous page had a square root in it, but if you remember correctly, we can write square roots as that whatever's underneath the square root to the 1/2 power, and then the minus the natural log of 7. So, now that we have it written with an exponent, we can take that exponent and move it out front using that power property. We got 1/2 natural log of 3x minus 5 minus natural log of 7. So we've broken that one up as much as possible. Now the last part here, we're asked to condense these two logarithmic expressions. So number one, we've got 2 times the natural log of x plus 2, minus the natural log of x. What I'm going to do on that one is we're going to use the properties in reverse. We're going to take the separate things and combine them into one. So using the opposite of the power property, I'm going to take that number out front and move it back into an exponent. So we have natural log of x plus 2 squared minus natural log of x. Now we can use the quotient property because we have one log minus another. So it's going to be natural log of x plus 2 squared divided by x. So we can combine them into one single log. For the last one, I want you to try that on your own. So pause the video, take 3 log of x plus log of 4, pause the video, see if you can combine them into one. Okay, you paused, we're back. So I'm going to do the same thing. I'm going to take my 3, move it back into an exponent. So I have log of x to the third plus log of 4. Now, with these, we've got one log plus another log. That kind of looks like that product property, so we can combine those and to make it log, well, we don't have a base, it's base 10, of x to the third times 4. I'm just going to write that as 4x to the third. And that's all.